Welcome to Smart Data's YouTube channel. Myself 𝗟𝗲𝗃𝗲𝗃𝗲. Today we are going to discuss Codechef Starters 192 problems. Let's dive into the video.
Okay, let's quickly start with problem. Let's go through problem statement. So the given problem statement is 𝗨𝗧. So there are n numbers written on a blackboard. The ith number is denoted as a of n. So there is nothing but as you are seeing here, there are n numbers on blackboard that is nothing but array of elements. Okay, and a of I represents the ith number. Okay, and the blackboard is said to be good if for each pair of indices I comma j with one less than one less than or equals to I and I less than j, j less than or equals to n. This sum a of I plus a of j is an even number. Okay, so to keep it short, if you pick two values, if you pick two numbers in the array, okay, which is of different indices, and if you add them, and if they are equal, if they form even number, then it is good. Okay, so the blackboard might not be good initially, so you want to make it good. To do this, you can perform the following two types of operations. Okay, so blackboard initially it might not be good. What does it mean? So if you pick two numbers, let's say 1 and 2, if you add them, the sum is odd, so it is not good. Okay, so initially it is not good, so you want to make it good. So it's our duty to make it good. To do this, we can do following operations. One, erase a 2 from the blackboard and in its place, write two occurrences of 1. So you can pick 2 and you can write two occurrences of 1. And of course, for doing that, you need at least one occurrence of 2. Similarly, erase two occurrences of 1 from the blackboard and in their place, write a single occurrence of 2. So simply, what you can do is if you are having two, in place of two, you can write two ones, or if you are having two ones, simply you can write two. Okay, so you can do vice versa. But for splitting two into two ones, you need at least one two. Okay, and similarly, if you want to convert to two, you need at least two ones. Okay, so if you are having three ones, what you can do either two one or one two. Okay, but you cannot convert to two twos. Fine. The above operations can be performed in any order, and each operation can be used however many times you like. Find the minimum number of operations needed to make the blackboard good. It can be proved that's always possible to make the blackboard is good. So every time, no matter whatever the given input is, you can definitely make blackboard to good. Okay, and we need to count minimum number of operations to convert the blackboard to good. Okay, so the given constraints are t is 100, n is 100, and a of I, if you observe, we will have elements either 1 or 2 in the given array. Okay, so can I simply say we need when we pick two numbers in the array and when we add them, the pair sum should be even. So if we are having two ones, and what are the sum? 2. Can I simply say it is even? And if you pick two twos, and if we add them, what is its sum? 4. If you pick 1 2 or 2 1, can I simply say their sum is nothing but 3, which is odd? So can I simply say we are given an array which consists of 1 and 2. Now, simply to make it good, can I change the question to we should convert all the elements in the array from 1 to 2 or 2 to 1, so that so the array will become good. So now let's take first example 1 1 2 2. Okay, first sample input 1 1 2 2. Now we need to convert this to good. So for converting it to good, can I simply say we should convert all the elements in the array to either 1 or 2. Okay, now which is better, which is should. So one operation will be we can convert two ones to two, or each two to two ones. So when you're converting two ones to two, can I simply say this is one operation? And you are able to merge two ones. That is nothing but we are reducing two elements. We are affecting two elements. Whereas if you are making one two to two ones, can I simply say you are affecting one element? So if you merge two ones, can I simply say the elements are getting reduced? Yes, sir. So for converting two twos to ones, you need two operations. And for converting two ones to two, you need only one operation. That's what I'm trying to say. Okay, for this you need two operations. For this you need one operation. So can I simply say if you're having equal number of twos and ones, if you're having equal number of twos and ones, which is better? Will you convert all ones to twos or all twos to ones? Can I simply say if you convert all twos to ones, it will take two operations, whereas here it will take only one operation. Okay. So our aim will be firstly we will try to convert all ones to twos. So it will take less time. Okay. Uh, so in this scenario, we are converting all ones to two. So it will take one operation. Now you are having four ones. So do you need to change anything? Already every element is one. Yes or no? So you don't do anything. Now coming to third example, we are having three ones and two twos. So for this for converting two twos to ones, we need two operations. And if you look at ones, we are having three ones. So one pair you can convert to two. But what about the other value? So can we make this array? Can we make this array completely to? Can we convert the entire array to have all elements as two? No. Why? Because even if you convert one pair of ones to two, so if you convert one pair to two, still one element will be left. Okay. So in this scenario, we'll only have choice of converting. We only have choice of converting all twos to ones. Okay. So to keep it short, what kind of scenarios we might have? So firstly, we can take counts of ones and we can take counts of twos. So here we will be having two kinds of scenarios. So ones, a number of ones can be either odd or even. So when the number of ones are odd, can we do anything? Can we convert all the ones to two? No. Why? Because at least one will be left. In this scenario, how many twos are present? Those many operations we need to perform. Okay. So let's take one scenario where ones, twos, ones are five and twos are three. So in this scenario, we cannot convert all ones to twos. So simply we need minimum operations as three. Okay. Minimum number of operations as three. Next, ones are even. Okay. We can remove this case. Now ones are even. Now what we should do? Can I simply say? Can I simply take something like this? Like when ones are eight and twos are five. How many operations will it take? So simply I can convert all ones to twos. So for two ones, it is one operation. Okay. So for eight ones, how many operations will it take? Simply the number of ones by two. Yes, sir. In this scenario. Now similarly, if I'm having if I'm having twos as two, still will I go for converting ones to twos? If you see, if I convert all twos to ones, it might take only two operations. But if we convert all the ones to twos, it will take four operations. So I should pick minimum. So ones are odd, whenever ones are odd, so simply our logic will be if the count of ones are odd, then we don't have other choice. We need to print our answer as count of twos. Okay, count of twos. Else, if it is even, that means once we can convert to twos. But will we simply take ones by two? No, we don't know the minimum. So we'll pick the minimum operations for converting all ones to twos. That is nothing but count of ones by two, and all the operations for converting twos to one. That is nothing but number of twos. Okay. So this will be the logic for our First problem. Let's quickly code it. Okay, let's quickly code it up. I scanned number of test cases and size of array. Now, instead of scanning all the elements into array, we only need counts of ones and counts of twos. So what we do is we'll traverse for n times, and every time take an element, scan it, and if that element is equals to one, if that element is equals to one, then simply increment ones counter, else increment twos counter. Once we had count of ones and twos, now we can simply call some function like blackboard. Okay, so we call this function. We pass count of ones comma count of twos, and let's assume this will return us the expected output. Let's implement blackboard. Now here, so when we cannot convert array to all ones to twos, when the count of ones is odd, whenever the count of ones is odd, we cannot convert them to twos. So simply we'll return twos. If that is not the case, okay, if that is not the case, then what we will do? We can convert all ones to twos and or all twos to ones. In this scenario, we will simply pick the minimum operations. Okay, so that is nothing but how many operations we will take for converting all ones to twos? One by sorry, number of ones by two. How many operations will take for converting all twos to ones? Number of twos. Okay, we'll return minimum of it. So let's run the code. Okay, let's submit this. It got accepted. Okay, let's move to next problem. Okay, let's quickly start with second problem statement. And the given problem statement is the airport in Sheffland is a busy place. Today we will take a look at its security queues. There are n security queues numbered 1 to n. Initially, there are AI people standing in the ith queue. You are the last person in the first queue, i.e., the eighth person in Q1. Okay, so simply you are given, to keep it short, simply you are given array elements. Okay, simply you are given array elements from, let's say, instead of from 0 to 1, let's consider from 1 to n. Okay, and for every index you will be having some number, let's say 5, 2, 7, 10, and okay, and this is the first queue, and you are standing at the, you are the last person in the first queue. That's nothing but there are 5 persons for first queue, and you are the last person. Okay, now now let's move forward. Every second the following will happen. Okay, first point. First, you will either stay in the same queue or move to adjacent queue. So you will stay in same queue. Let's say you're having queues like this. So you are here. So either you will stay in same queue or you will move to adjacent queue. That is one thing. And the second thing will be, and when you are moving as well, you should check carefully whether the queue is present or not. Like if you are in the first queue, you cannot move towards left side, and when you are in the last queue, you cannot move towards right side. Okay. Now, the second point will be then the first person in every queue will complete their security check and so simultaneously every time, like if you are having 5 members, 2 members, 7 members, 10 members, 3 members. So first second, every person, every person will be deducted. Okay, it will be something like that. And second, Again, this will become 3, this will become 0, this will become 5, this will become 8, this will become something like that. Okay. So for every second, count of every element in the array will get reduced to keep it short. Naturally, you'd like to finish your security check as soon as possible. What's the minimum number of seconds you will need if you act optimally? Okay. So simply the problem statement is nothing but you're having something like this. You need to finish your security check as soon as possible. Okay. Now let's quickly go through sample input output. So your given first sample input is nothing but 5 to 1. So 5 to 1, I'm directly taking it as something like this. You're having 5 to 1, 3. So it will be something like this. 5 members, 1 person, sorry, 2 persons, 1 person, and 3 persons. Okay. Now, in first second, what you can do is either you can stay here or you can move forward. Okay, either you can stay here or you can move forward. So if you see carefully, you are having 5 to 1, 3, and you are the last person. Okay. Now, for you to move to other queue, it might take 1 second. Yes, sir. So let's say in first second, instead of staying here, I move to next one. Okay. And when I'm moving simultaneously, what happens? In that first second, all the members who are at the beginning will finish the security. Yes, sir. So what happens? It will become firstly you moved here, so that will be nothing but 4 3 1 3 in 1 second. These two things are happening. Okay, this is one thing. And second thing, every person who are standing in the first, every first person in the queue will finish with the security. So what happens? This will become 3. This will become 2. This will become 0. This will become my bad. This will become 2. Okay. Now it is something like this. So you move from here to here. Now in the next second, again what you can do? Either you can move to next row, or I mean next queue, or else you can stay here. So let's say you move to next queue. Then what happens in second? Let's say it is something like this. You move from this queue to other queue. So this will become 1. This will become 1. This will become 2. Okay. And now what happens? You need to in the second itself. Every first person will be finished with this. Okay. So if you see in the explanation part, so that means we are done scanning in 2 seconds. Now if you look at second sample input, second sample input. Okay, if you look at second sample input, you are having 4 and 5. So you are the last person. That means you are at this place and there are 5 people towards that side. Now will you stay in the same queue or will you move to other queue? So simply the other queue is having more people. That means it will take more time. So simply you will wait here, which will take 4 seconds. Okay. So that is the reason why the output is 4 for second sample. And if we take last sample, that's nothing but 73562. So can I simply say you're the seventh person in this queue? Now will you to move towards right side or will you stay in the same queue? Can I simply say you will move towards right side? So you will move towards right side. Now, simply when you move towards right side, can I simply say one person is getting added? Yes, sir. Can I simply say one person is getting added? Now, that means this will become 4. Now, how much time will it take for you to finish your security? Can I simply say 4 seconds? Yes, sir. And will you move for further right side? If you see, you're having 2 at the end, which is very less time. But if you observe carefully, how much time will it take for you to move from first queue to last queue. That is nothing but fifth queue, fourth index queue. So can I simply say it will take 4 seconds? So by 4 seconds, the number of people here will become zero. But still, it will take you 5 seconds. It will take you 4 seconds. Okay. So anyways, the minimum time that you will take to finish your scanning will be 4 seconds. Now, simply what should be our approach? Simply, what should be our approach? So here, if you observe carefully, you're at the first element. You're at the first element. So let's say if you are given array element is something like this. So let's say the first element is x. So how much time will it take for you to move to first index place? Can I simply say x plus 1? And for moving towards second index place, can I simply say 2 seconds, then 3 seconds, then 4 seconds, so on. Okay. Now let me say x is nothing but 3. X is nothing but. So for you to finish your scanning, for you to finish your security check, can I simply say it will take 3 seconds? Okay. So if you move to first index, it will take how many seconds? 1 second. Okay. Then my bad, like not x plus 1, x plus 2, x plus 3. It will take 1 second, 2 seconds, 3 seconds, 4 seconds, so on. Yes, sir. So if you go to first index, so let's say you're having values like this. Let me take another array. Okay. Let me take the values as something like this. So let's say 3, 5, 2, 1, and so. Now, how much time will it take for me to finish my security check in the first index? Can I simply say my answer can be 3 seconds? It is my possible answer. Now, for moving towards right side, can I simply say it will take one extra second and 1% will be reduced. 1% will be reduced. That is nothing but again, even that 1% got reduced. Can I simply say again you will end up adding one extra person because you are getting added to it. Yes, sir. So can I simply say 1 second plus 1 second plus so you take 1 second for traveling to that place. Now here, at that point of time, one person is getting reduced. Yes, sir. So when you are here, no one will be reduced. When you are here, one person will be reduced. Okay. And when you move to this place, two persons will be reduced. When you move to this place, three persons will be reduced. Okay. And when you move to this place, four persons will be reduced. Yes, sir. So that means nothing but every time 1 second is getting reduced. Yes, sir. What is 1% is? Is taking away 1 second for security. Okay. So when you are moving forward, when 1 second is adding here, 2 seconds are adding here, 3 seconds are adding here, 4 seconds are adding here. At the same time, persons are getting reduced. Yes, sir. So that means when you are here, to come here, you are taking 2 seconds, but still two persons are getting reduced. Okay. So initially, if you are having 6 people here, it might take 2 seconds. It might take 2 seconds for coming here. But in the meantime, can I simply say two persons are getting reduced, which is nothing but equivalent to it is getting reduced by 2 seconds. So can I simply cancel this? And at the end, can I simply say this is the time taken by you to finish this or to finish security check at that particular index? Yes, sir. You got my point? So if you are having array like this, 0, 1, 2, 3, 4, and if you are having 3, 5, 2, 1, 7. Okay. So if you take this particular checkpoint or this particular to finish to finish security check at this particular queue, how many seconds will it take? For you to come to this, it will take 4 seconds. Okay, it will take 4 seconds. But meantime, can I simply say four persons will be reduced? Yes, sir. So can I simply say these two things will be cancelled? At the end, this much time you will take for finishing at this. Okay, and there is another thing for this particular problem. Like when you are here, when you are here, when you are here, if you consider this. It will take you 3 seconds to come. Okay, but how many persons will be reduced? Will it be minus 3%? If you say there is only 1%, so can I simply say only 1% will be reduced? So the minimum time it is required to finish your security check at this place is nothing but 3. Yes or no? It will be 3 seconds. Why? Because you just need to come here 1 second, 2 second, 3 second. By that time, no one will be present. So it took you 3 seconds for travel. Okay. Similarly, when you are here, for coming here, how many seconds will it take? 2 seconds. And how many persons will be reduced? 2 persons will be reduced. Yes, sir. So how much time will it take? Can I simply say these two will be cancelled? So to finish your security check at this queue, it will take 2 seconds. Okay. So simply, what can be your approach? So initially, okay, initially this can be your error. And what can be your answer? If you finish your security check at this place, it will take you 3 seconds. Okay, this can be possible. Now we need to look for minimum answer. So can I simply say to travel here it will take 1 second. Okay. By the meantime, 1% will be reduced. So how much time will it take for to finish my security check here? Can I simply say 5 seconds? And is it better than previous answer? Hmm. So we'll move forward. So to move here, it will take 2 seconds. That is nothing but can I simply say it will take index seconds? If you are at ith index, it will take I seconds. Okay. So here it will take 2 seconds. Meanwhile, 2% will be reduced. Yes, sir. So it will take 2 seconds to finish your security check here. And can I simply say it is better answer than previous? Yes. Now, now you are here. So how much time will it take for you to finish security check here? Okay. So there is 1%. So by the time you come here, that is nothing but 3 seconds. This person will be left. So can I simply say there will be no person and you will be the first person. But for traveling till here, how much time it took? 3 seconds. Yes, sir. 3 seconds. So every time what we should pick? We should pick maximum of index or value. Maximum of index or value. And every time we should update the index or value. Every time we need to update this with minimum of answer. We should try to minimize our answer. Okay. Similarly, if you take another array, let me modify this array. Let's say this is 4, this is 5, and instead of 2, let's say you are having, okay, let's say you're having 2, or else let's say you're having 3, okay, and let's say you're having 5 here, or else let's say you're having 6 here, and 7. So simply how much time will it take for you to finish scanning here? It will take 4 seconds. Here it will take 5 seconds. Here it will take 3 seconds. Okay. Instead of 3, if you are having 1 here or 2 here, it will take minimum of this index comma this. Sorry, maximum of this index comma value. Okay. So if you are having 1 here, that is nothing but it will take 2 seconds. Okay. Similarly, here if you are having 3. Okay. How much time will it take? Here it will take 6. Here it will take 4. Okay. Now we need to pick minimum out of all these values. So this will be our answer. Now let's quickly now let's quickly write code for this. Okay. Let's move forward. Okay, let's quickly code this up. So initially our answer will be array of array of 0. This is nothing but first pair. Now traverse from I equals to 1, I less than u, I plus plus. Every time what we need to store in our answer, that is nothing but we are trying to get minimum value in our answer. So we should update our answer every time with minimum of uh, answer comma. So we need to pick maximum of at every point of time that particular index. That means the amount of time that we took for traveling to that index. Then how much time will it take for us to finish it? So let's say the number of amount of time that we took to travel to the particular index is very less. Let's say we took two, will take 2 seconds to travel to index two, and there are five people there. Okay, so the time we go there, by the time we go to index two, two persons will be reduced, but still three people will be. And again, add an additional person. Our value will be added to it. So we'll simply have array of five plus finally return x. Now let's submit the code. That's it. Let's move to next problem. Let's quickly start with the third problem. So the given problem description is for an array B of length m, we can define the following. The prefix sum of array of B is an array P also of length m such that P of I is nothing but B of 1 plus B of 2 plus so on up to B of n. B is called good if every element of its prefix sum array is not a multiple of 3. So simply you are given an array and if you take prefix sum of that particular array. So prefix sum of array is nothing but, so let's say if you're given arrays B and it's having values like 5, 2, 3, 1, 7, something like that. Then prefix sum of B will be nothing but, here it will be 5. Here prefix of 1 is nothing but, prefix of 1 is nothing but, it is sum from 0 to 1. So it will be 7. And prefix of 2 is nothing but sum from 0 to 2. So that will be nothing but 10. Then it will be 11. Then it will be 8. So every element, okay, if you take prefix of it, uh, the array B is called good when prefix, if every element of its prefix sum array is not multiple of 3. If you take 5, it's not multiple of 3, 7, not multiple of 3, 10, no, 11, no, 18, yes, it is multiple of 3. So that is the reason we cannot call B as good array. So if you remove this last element, so then the array B is good. Okay. So everyone, I hope everyone's here with prefix sum array and the problem statement. There's nothing but how to validate whether B is good or not. Now, for example, they provided us some example like B is something like this, is good array, and in other hand, when B equals to 1122, it is not a good array. Okay. Now you are given an array A of length n. Every element of A is either one or two. So we are given an array A of size n, and it contains only ones and twos. At most once, you can reverse a prefix of A. So simply if we are having A, if we are having array, so what we can do is we will have only ones and twos. Okay. Now at most once, we can pick some part of this array from starting to some particular index, and we can swap it. Okay. Only once we can perform this operation, and we should check whether it is possible to make A is good as well. Okay. We should check whether A will be turned to good if we do this or not. We should do it. Okay. So simply let's go through sampling. Now your given array is 1, 1, 2, 1, and if you take prefix of it 1, 2, 4, 5. So it's already good. We don't need to do anything. So it is good. Yes. Then 1, 2. No matter whatever you do, even if you reverse this, sorry, even if you reverse this, it is not good because its sum is 3. Okay. So no, it is not possible. Then we are having 1, 2, 2, 2, 1. Okay. Now if you take prefix sum 1, 3, 5, then 6, 7, 8. Now, if you see, one occurrence of it is divisible by 3. So now can you swap something so that it will become non-divisible of 3? Okay, you can pick one part. Will you pick this part or will you pick this part? So if I simply swap this part or if I simply reverse this part, then what happens? Then what happens? Can I simply say it will be 2, 4, 5, then 7 and 8? That's all. So if I simply reverse that part, then it will be 10. And again, if there is another occurrence of, let's say here again you're having 1, then you're having, that means nothing but here it is 9, here it is 10, 11. So even if you reverse this part, you are able to get rid of this. But again in future, if you are getting 9 and 11, then it is not possible. Okay, again you are not allowed to reverse the error. Okay, so if you take till here, it is yes, we can reverse some part of it and we can make it good error. But for continuing further, like let's say if you are having something like this, we can reverse this part, okay, and we can make the array as good. But further, if you are again having another 1 and 2, okay, another 1 and 2, what happens here? It will become 9 and 11. So even if you reverse this part, you will eliminate divisible of 3 in this prefix part, but you cannot reverse again, so it will be not good. Now moving forward, again 1 to 1 to. No matter whatever you reverse, the final sum will be 1, 3, 4, 6. When the final sum is 6, that means nothing but sum of entire array. If it is divisible by 3, can we do something? We cannot do anything. No matter how many ways you rearrange it, the sum remains same. So by the end, what happens? The last element will be divisible by 3. So in that scenario, we cannot do it. Okay, so if sum of entire arrays uh, divisible by 3, then no matter how many times you rearrange, no matter what you do, we cannot get answer. Okay, so it will be no. Then again, we are having 1, 1, 2, 1. Now simply take prefix sum 1, 2, 4, 5, 6. Again, the entire sum of the array is divisible by 3, so we cannot do anything. Then now we are having only 2. So when you are having only 2, no there is no element which is divisible by 3. So we don't need to do anything. Okay. Now let's see what we can do. What can be our approach? So to firstly, if you understood till here, pause here and try on your own. Okay. And if you try and if you're not getting, let me give you a small hint. Try to work on it. If you're still not getting it, you can come back again. So let's say if you're having two elements, one one, then you're having different elements. Again, if you're having two same elements and one different element, can I simply say in these two combinations, the value that you get will not be divisible by so, so if you are having two same values and one different value, then definitely the starting value, the starting sum will be not divisible by not divisible by 3. Okay, so take this as an and see what you can do. Now, simply what we will do is, so we are having array like this. So simply what we do is, let's take this array, what we mentioned previously. Every time we need to check, let's take prefix sum while we are scanning itself, let's take sum of the entire array. Okay, so 1, 3, then this will be nothing but 5. Okay, so sum is initially 1, then 3, then 5. So whenever the value is divisible by value is divisible by 3, take some variable and keep incrementing. Okay, so here it occurs once, so increment it. Then 5, then 7, okay, then 8, then 9, again increment it, then 11. Okay, so finally your sum will be 11. So is it divisible by 3? No, That means there might be a possibility where it might. Okay, and if in any case if z is zero, that means there is no occurrence of divisible of 3. So in that scenario, you can directly print yes. Okay, so we cannot print no because we don't know whether it is whether there can be possibility or not, and we cannot print yes. Why? Because there is occurrences of divisibles of 3. Okay, now what we should do? Now, as I mentioned here, keep keep moving forward. The moment you come across two occurrences, the moment you come across two occurrences which are same, simply reverse this part. Okay, now the array will be 2 2 1 2 2 2 1 2 1 1 2. Now what happens if you see 2 4 5 2 8 9? Again, we came across this, but can we do anything? We can only swap ones. Okay, so in this scenario again we cannot do anything, so we'll print. Now let's say if you're having something like this, so you're having 1 2, then that is nothing but 1 3 prefix, then 1 again, let's say it is 4, then let's take 2, so this will be 6, then let's take 1 1, this will be 7, this will be 8. Now simply z is 2, and can I simply say sum is 8? Okay, we cannot say it is bad array. Why? Because we cannot directly say why, because there can be possibility because sum is not divisible by 3. At the same time, we cannot say it is already good array. Why? Because we had two occurrences of divisible by 3. Now again, if you apply the same, so move forward, move forward, move forward, move forward. Now when you came across two ones, simply reverse it. So reverse the entire array. That is nothing but 1 1 2 1 2 1. Now again take prefix sum 1 2 3 4 5 6 7 8. Now did you come across any occurrence of prefix value which is divisible by 3? No. So in this scenario, what you can directly return. Okay. So you got my point. Our approach is simple. Firstly, we'll calculate sum, we'll calculate z. If sum is divisible by 3, then in that scenario, we cannot do anything. We'll directly return no. If z is 0, we can directly return yes. Okay. And if sum is not divisible by 3 and z is greater than 0, then we should look for a value, look for the part of array which we can reverse. So how can you look for it? You should look for two occurrences which are occurring one after the other. When there are two like terms occurring one after the other, then simply reverse that part. After reversing, again take the prefix sum. Again, if you come across any value which is which is divisible by 3, in that scenario, you should directly return no. Or else, if you didn't come across any occurrence of divisibility of 3, then we can return false. I mean, like we can return yes. Okay. I hope everyone are clear with our approach. Let's quickly write code for this. Okay, let's quickly write code for this. I already wrote some part of it, scanning test cases, scanning in, and scanning array. At the same time, I'm maintaining two variables, sum and z. So every time I'm adding sum, okay, and whenever sum is divisible by 3, I'm incrementing z. So I'm directly calling good function, and if we return true, it will print yes. If return false, it will print no. So simply when what we can write, if sum is divisible by 3, in that scenario, can we do anything? No. So if sum is divisible by 3, so we can directly return false. Okay, that means no. And if z is equals to 0, if z equals to 0, then we can directly return true. That means it is good. Okay, we didn't come across any occurrence of some value which is divisible by 3. Now, what you can do? Now again take sum as 0. Okay, if it is not satisfying two conditions, again let's do this. Let's repeat the process. Okay, let's take sum as 0. and z as 0. Now let's try for an occurrence where we can reverse this. So let's traverse through the array. Let's traverse from I equals to 1, I less than or equals to n minus 1. Okay? Why? Because if first two elements are matching, we don't need to start. It makes no sense. Okay? So we'll start from first index. And every time we'll be comparing with next index. So we'll be traversing till n minus 1. Now, if array of 5 or else it's a of I equals to a of I plus 1, then we need to reverse it and we need to break it. Okay? So what we can do for reversing? So let's call reverse function. Okay? So we will pass array and let's say we pass index and let's pass ns to this. So it will simply reverse the array. Now after reversing it, again we need to check whether it is whether we are getting any prefix value which is divisible by 3. So again run the array for I equals to 0 or less than n I plus 3. And this is still less than n. Now simply what we should do every time, take sum of a of I, okay, and if sum is divisible by 3, if sum is divisible by 3, then increment z. Okay, the sum is divisible by 3, then increment z. Finally, if z greater than 0, return false, else return. That's it. Okay, you can also directly return from here as well. Now let's implement this reverse function. So let's quickly implement reverse function, or else you can also use inbuilt function. Okay, my bad. So instead of implementing it, I'm directly using inbuilt function. Okay, this will reverse from starting index to that particular index. Now after reversing, we'll do the following operation and we'll return false or true accordingly. Let's submit this code. Okay, that's it, guys.
That's the wrap up, guys. If you enjoyed the content, please like, share, and subscribe to Smart Intel's YouTube channel. Thank you.